This is our last video for Unit 2 and it's on free fall. By the end of this video I want you to be able to explain what free fall is and also to use some equations to calculate the instantaneous speed of an object that's in free fall, calculate the time of free fall, and calculate the distance of free fall. So those are going to be some equations after we talk about what free fall is, and then I want you to be able to explain what air resistance is and how that affects an object in free fall. Be sure that you're taking notes in your packet, and you can use those notes to take a video quiz at the end. And they'll be helpful for you to complete the practice problem set too. So, the first thing, before we talk about free fall, we should understand what it means. So free fall is when something is falling, and it's falling only because of gravity's pull on it. So, you can't throw something and have it fall. That's something that just has to drop straight down. Actually, something in free fall, if it goes straight up and straight down, then it could be in free fall too. So when gravity pulls on something, on Earth, gravity pulls on something in a very predictable way. And we'd say that the acceleration of an object, if it started at rest and then gravity pulled on it, the acceleration of that object would be 10 meters per second squared. Now that's a nice round number that we use to make our calculations easier, but actually the number is closer to 9.81 meters per second squared. But for this class, we're just going to say that the acceleration due to gravity is 10 meters per second squared. Now the symbol we use for acceleration due to gravity is little g. So it's actually called little g, and it's a lowercase g, and lowercase g, little g, remember, it stands for acceleration due to gravity. A lot of young physicists will just say that little g stands for gravity, but what it stands for is the acceleration due to gravity. Now this unit is about linear motion, and what we've been talking about so far is linear motion on the ground, so things pretty much moving left or right. Or when you did the lab where you're moving towards or away from a motion sensor, that was also linear motion. But free fall, up in the air or down to the ground, that is linear motion too, because that's in a straight line up and down instead of side to side. Now the equations that we used for an object that moves from side to side or flat on the ground were these. Velocity equals displacement over time, or speed equals distance over time. And then also we used our acceleration equation. Acceleration is the change in velocity over the change in time. So the thing about physics, if you haven't noticed yet, a lot of physics is about finding things that are predictable and using math to predict how an object is going to behave. So an object that's in free fall is very, very predictable, and we're going to use slightly different equations. So we're going to use this equation where it's the instantaneous velocity equals the acceleration due to gravity times time. So this is instantaneous velocity. We said that's acceleration due to gravity, which is always going to be 10 meters per second squared. It's a constant, it stays the same. And this is time in seconds, and velocity is meters per second. Acceleration is always going to be predictable in little g, 10 meters per second squared. And then we're going to use this formula too. D equals 1/2 gt squared. So distance in meters equals 1/2 times acceleration due to gravity times time squared. Now this squared right here, it only has to do with time. So don't square everything, just square that time. Let's do a couple of practice problems. So here are those equations written nice and big. And this one, remember, was for instantaneous velocity. So that's when you want to know how fast something is going. When you want to know how far something is going, that's the distance, and you would use this equation. Now remember, these equations are only good for things that are in free fall. They aren't good for things that are traveling on the ground. Not good for that. So let's check this one out. It says, what is the speed of an object that has been in free fall for 13 seconds? So it's asking us for the speed, and is the speed how fast or how far? It's a how fast, so we're going to use this equation. And it gives us a time is 13 seconds. So we don't know v, and we do know that time is 13 seconds. And here's little g, our friend, is going to be 10 meters per second squared. So all we have to do is multiply these together, and you get 130. Now one of the toughest things that you're going to have to remember is putting the right units. It's a velocity, so those units are going to be meters per second. Let's try another one. If an object in free fall reaches a speed of 190 meters per second, how many seconds has it been falling? Is that how fast or how far? It's kind of neither. But what you're given here is you are given a how fast. You are given a velocity. And it says how many seconds, which is a time. So the equation we're going to want to use is this one, where v is given to us as 190. We know that little g is 10 meters per second squared, and we're trying to figure out what t is. We can divide both sides by 10, and that gives us t equals 19 seconds. Hopefully you'll see that using this equation is actually pretty easy. Let's try another one. If an object has been in free fall for 3 seconds, how far has it fallen? What's it asking us to find? It's asking us to find how far. And that's a distance. When it says that the object has been in free fall for 3 seconds, that's a time. And now we can work right with this one. So we don't know the distance, so I'll leave that as d. 1/2 times 10 is little g times 3 squared. And it's only that 3 that's going to be squared. Let's work out some of these numbers. I'm going to do two things at once. I'm going to multiply this 1/2 and the 10 to make that 5. And then I'm going to square that 3 to make it 9. And then this gives us a distance of 45. Now the units for distance are going to be meters, so don't forget to put your units. How about this one? How much time does it take for an object to free fall for 125 meters? It's asking us to find time, and it's giving us a distance. So let's check it out. We're going to use this equation and plug in 125 for distance equals 1/2 times g is 10 meters per second squared times t squared. Let's simplify these numbers. We can get 125 equals 5t squared. We divide both sides by 5, and then we get 25 equals t squared. Now to unsquare this t, what we have to do is take the square root of both sides. And then what we get is t equals 5. The units for time are going to be seconds. So those are some example problems, and now I want to try something else, another sheet that you've been given. So one of the sheets that you're going to have to do is this free fall table. And what it's giving you is the time in seconds. So time is given to you for every one of these. It's asking you for the instantaneous speed, which is v, and it gives you a distance, and then it's asking you for the average speed for the whole free fall. Now this one's a little bit tricky, so we'll save this for last. So, remember our formulas. We have instantaneous velocity equals little g times time. And we have distance equals 1/2 gt squared. So on this, it gives us time is 0, and that's going to be really easy, because anything times 0 is going to be 0. Now next, at a time of 1 second, we would plug in 1 for these, and that would make the velocity 10 times 1, which is 10 meters per second, and the distance 1/2 times 10 times 1 squared. Now 1 squared is 1, and 1/2 times 10 times 1 is 5. So it will have fallen 5 meters. Now I'm going to do the next one, and then you'll complete the rest by yourself. So this one is gt, or 10 times 2, which makes it 20 meters per second. The distance fallen is going to be 1/2 times 10 times 2 squared, which is 5 times 4, or 20 meters. And now I want to show you how to do this average speed. This is actually a formula that we've known for a long time, but we might not have used it, and that's v equals d over t. So in this case, I know I told you that keep thinking about that as flat ground, but in this case, we can use that formula. So the average speed, the total distance fallen is 0 meters divided by 0 seconds, and that's going to be 0 meters per second. Here, the distance fallen was 5 meters, and the time was 1 second, so the average speed is going to be 5 meters per second. For the next one, we've gone 20 meters, and it's taken 2 seconds, so our average speed is going to be 10 meters per second, and so on and so on. So, let's talk about our last objective, and that is, what is air resistance? What we've described in all of these equations are only for objects kind of in a vacuum. So what a vacuum means is that that's a situation where there's no air. You've probably, I don't know if you've skydived before, but you've definitely seen somebody skydive, and how they kind of float down to the ground is due to air resistance. So a person is flying down to the ground, and the air is kind of pushing them back up. And you've seen it where a skydiver can kind of float as they spread all of their limbs out, like this person. Or, if they stay in a nice straight line, then they can fall really fast because they have less air resistance. So why does this happen? Well, air is atoms, so when you're falling, or when an object is falling, it needs to push air out of the way. And this is going to keep an object from accelerating at 9.81 meters per second squared. Instead, the object is going to slow down. So, for us to use the numbers that we do in our calculations, things aren't actually going to behave perfectly like that, but it's going to be because of air resistance. So remember, air resistance is the resistance by the air to something that's in free fall from moving in an ideal way. Air resistance is going to slow an object down in free fall. And we'll talk about that a little bit more tomorrow, but I wanted to introduce the concept to you right here.